of the National Space Science Exhibition 2022. We are delighted to have Nandini Harinath from URSC ISRO today amongst us. Nandini Harinath is a senior scientist working in the Indian Space Research Organization ISRO for the past 27 years. She is presently the Deputy Director, Spacecraft Operations at ISRO, and she has worked on over 20 satellite missions in key designations to date. She was the Mission Design Deputy Operations Director for the Mars Orbit Mission, or popularly called MOM. She was the Mission Director for RISAT 2B constellation of satellites and resources at 2A satellites. She has several publications related to the work as mentioned, and has won several awards over the years, including the ASI Gold Medal in 2019, India Today Women in Science Award in 2015, and ASI ISRO Team Awards for MOM, SRE, Resource Sat 2, and RISAT. We're delighted to have you here. Please say
A warm good morning to all of you. Dr. Seetha, Dr. Nandi, Director. Thank you all for giving me this opportunity to be here. I feel really happy to see so many school children, especially today. It always gives a lot of energy to talk to, especially young people. So I just hope you will enjoy this talk, and at any point of time, if you think you need to ask something, you can always ask. So, yeah, so you want to switch up the lights a little more? You can start now. Yeah, so let me give a little bit of more introduction about myself. I work in a place called ISRAC. ISRAC is, you can actually, yeah. So ISRAC is a place where it's called ISRO Telemetry Tracking and Control Center. That's the place where we control all the on-orbit satellites, the low Earth missions. So my talk will be more focused on the low Earth missions. Low Earth missions means we generally mean satellite missions which are from say 300 to probably 1,500 kilometers in altitude. So the center where I work in, we take care of the satellite, and we take care, it's called housekeeping the way it is used in the nominal sense. We do housekeeping, make sure the satellite is in good health, program the satellite for the payloads, whatever it is meant to be, and then we also determine where the satellite is all the time. We track the satellite all the time. So this is a brief introduction about myself. So yeah, so I have got an hour. You can just tell me when, if I'm exceeding my time. So today's lecture, I thought, actually Dr. Nandi suggested an interesting topic to tell you exactly about what goes on behind the scenes. So whenever you see all these big missions, you see missions like MOM and Chandrayaan on TV, and you read about them in the newspapers. But what exactly goes behind planning and operating the satellites? So the later half of my talk will be more on that, and the first half I thought I should tell you a little bit about satellites, because today, all of us know satellite and satellite data. We so much we are using it all the time. We are not even conscious of it. We are not. Let's say, for example, your mobile. It's not just for navigation, moving one place to another. The very fact that you have online classes, the very fact that you can order food on, an app. So all this, we are actually subconsciously, without really understanding that we are actually using the satellites that are there in space. So I'm going to tell you a little bit about how we are using these satellites. Yeah, so before I actually go to the slide, all of you, in fact, even right from an infant to a person who is the oldest and probably very well read and accomplished, every one of us is fascinated by space. Why do you think it is so? Because the minute you go outside and probably on your terrace and look up, you will see so many things. Haven't we not wondered, what is that thing that is moving in the space? Is it a satellite or no, it's moving fast. Maybe it's an aircraft. Where do I find the pole star today? So most of us have had these questions, and that is what is space is something that keeps all of us awestruck all the time. Like other fields that you probably study, you need to go to labs and you need to go to probably read textbooks to understand the subject. Here, the fascination or the inspiration just comes just like that. Just step out of your home and you get inspired. So that is the reason why space is something all of us are curious about. And when there is something happening in space, we are all it catches all of our attention. So coming back to from space to satellites. ISRO has really progressed from the time, I'm not sure if you can see it clearly, the way we evolved over years. So we have various categories of satellites, like you have the small satellites which are in the lower Earth orbit, and then you have this low Earth orbiting satellites. Basically, they are for remote sensing. They can carry a camera, they can be for surveillance, they can be for town planning, they can be just to see, take pictures of your city and see how you can make things better, or they can be to study the how the snow caps are melting, how the ocean water is raising, or how the winds are moving. It could be anything. So all these applications, they need the satellite to be kept in the lower orbits. Because you get a very good resolution. You are able to see things better when the altitude is lower. So that is why this is the second that category that you see, the low Earth orbit satellites. And then we have our own, I'll be talking about it a little more. We have our own constellation of satellites called NAVIC, which is used for navigation. I'm sure each and every one of you has been using the GPS. And never go out of the house without your mobile, right? And even to go to a small, one place to another nowadays, especially in Bangalore, we turn on the navigation even though I know the route. That is because you want to know which is the route which has the least traffic. So this has become so much a part and parcel of our life. So I'll be talking a little bit about that, and then we have this communication satellite. So all of you have read that if you need to use these satellites for communication, if you keep them in a geostationary orbit, it's always looking at your area of interest. So that way we always keep in contact with the satellites. But of course now there is new concepts coming. Even in the lower orbiting satellites, you can have whatever you can do with one satellite, you can have a constellation of satellites which will give you the constant coverage for communication. So ISRO of course has all these communication satellites placed in the geostationary orbits. Of course we have the most interesting ones are the science missions, the ones that actually catch public eye. The AstroSat we know has given so many good results, and then all of you know about Chandrayaan 1 and 2, and of course Mangalyaan of course is known to everyone. So these are the science, we call them the science exploration missions. They are specifically meant for science. Okay. Yeah, so this is more about how the satellites are basically eyes that we have in the sky. So they're constantly looking. They're constantly looking at your region, and they're constantly looking out for so many changes that are happening in your region, or in fact on the planet itself. So you have this, you can use it for agriculture. People actually, the agricultural ministry takes data from us. They actually know how the crop is going, how much yield one is getting, which are the crops which are not growing properly. So all these, this information is actually collected by the satellites and then given to it will be coming to a science center from where it is disseminated to different users. So then you also have these ocean applications. I should tell you that I'm sure all of you read about OceanSat 3, which was launched on November 26. So basically this is a very interesting satellite. It has payloads that will actually look at the colors in the ocean. It's called the Ocean Color Monitor. It gives very, very pretty pictures. So it will actually tell you where the phytoplankton is and which is actually in the ocean where there is a density of chlorophyll. Why do you want to know where the chlorophyll is? Because you want to know the fishes are there where the chlorophyll is. So that will indirectly tell you where the fish is. So these are some of these applications which are really useful to the country, to the fishermen. And it also has a scatterometer which will tell you all about the wind. It will tell you how the winds are moving, if there is a cyclone, what is going to happen. So it is enormous amount of data to the scientists. So yeah, again, urban planning, disaster management is one important application wherein you know if, in fact the satellite data has saved thousands of lives. You know if there is an impending cyclone coming and you can actually evacuate people from there, and that is all done by using the satellite data. Yeah. So let me just go on, when I was talking about imaging and when I was saying that the satellites they're like eyes that you have in space, what exactly, how have we evolved over time? So if you look at our first satellite, there is something called your resolution. So all of you have mobile cameras, you buy more expensive mobiles. Not so because of the communication, whether you have a 10,000 rupees mobile or a 1 lakh mobile, you'll still hear the same and you still have all the basic features. But what really is improving is your other software and the camera. So most of us pay money for the camera. So here and what actually determines that the camera is good? So the optics and the resolution. So here when you say earlier we used to have a resolution of something like 1 kilometer. That means if you're looking at an image from space, you can't distinguish between features that are less than 1 kilometer. That's the best you can see. But today the technology has evolved and the satellites, the most recent satellites, though I've said 0.5, we are getting almost up to 30 centimeter. So even if there's a small truck or anything which is bigger than 30 centimeter, in fact a truck is much bigger I should say. So anything bigger than 30 centimeter, you can actually detect that from space. So that is what is happening to the technology today. And there are three types of key important features that we look for when we look at a satellite image. One is the resolution, and another is if I've seen a location today, when can I see it next? So how fast can I see the same place over and over again? So we call that as temporal resolution, and then we have a spectral resolution. So whatever energy that you're collecting in, that energy, how many bits of data can you represent the energy in? So that is our spectral resolution. So we really, you can see that we've evolved from the time of Bhaskara to what is happening today, wherein you are getting a very, very high resolution. In fact, many times you will not even know if it's an aerial image or a satellite image. Some of these images are that good. So, and they're just not coming from the optics, but so many new methodologies that are coming both in the onboard and by the ground processing, wherein we enhance this image. So this is just to give you a flavor of So the center that I work in, it's called ISRO. Right now we have about 27 satellites. And I'm sorry this animation is not working. This was supposed to show you that these satellites that we have, these are all the satellites that ISRO has today in space. And these satellites, they show you how they are going around the Earth. You can see that some of them are going, pole to pole. Whereas some of them are going, close to the equator. There is a small inclination about the equator. So you have all these type of satellites in different orbits. Basically, why they are placed like this? Why not all of them are in the same way? Because different applications demand different things. Suppose, let's say, I want to see the entire Earth. Right? So then I can't have a satellite that goes only around the equator. But if I make a satellite go pole to pole, because the Earth is also rotating, it is going to cover this entire region of the Earth quickly, maybe in certain number of days. So that is the reason why different satellites have different types of orbits. So please move on to the next slide. So this is again was supposed to show the animation, and this is different ISRO satellites and how they go around. And this is the Mars orbiter mission. All of you know it had a very elliptical orbit. At one end, it was very close to the Mars surface, about say 300. We came as close to as 300 kilometers, and on the other end, we were almost 72,000 kilometers from the Mars surface. It was doing a long orbit. This is called an elliptical orbit. Yeah. So this is something that I already explained about OceanSat and how the OceanSat data is going to help the fishermen, and let me move on. Yeah, so coming to the other class of satellites, so we saw about remote sensing and how we really progressed with the science experiment satellite. So science is also, like I said, this space is something that all of us are curious about. All of us want to know, how the stars evolve, what is happening to the sun, what is happening to the moon. Basically, we want to know all about what is happening in the solar system and outside the solar system. So that is why we had so many science experiment satellites which ISRO has done till now, and you can see that we started with the Aryabhatta, and then how we progressed to Chandrayaan 1, and then we had YouthSat, we had AstroSat, we had some breakthrough results from the AstroSat, and then we had the Mars orbiter mission, which actually studied, gave us a lot of insight into the Martian atmosphere. A lot of papers presented recently in one of our workshops in ISRO, and of course there is we're going to have the Aditya and the Chandrayaan 3. So yeah, let me just move on. Yeah, so somebody in the morning was asking, right, how do we access all this data? So right from the type of the satellite we have different portals available in ISRO, wherein whoever is interested can actually register with the organization. There is one center called National Remote Sensing Data Center in Hyderabad, and for the science mission it's in Bangalore. It's called ISSDC. So you can actually register there as a user, and you'll be able to access maybe not all of ISRO's data, but many of these, especially the science missions, you will be able to access all this data from there. Yeah, there's one very interesting application. I'm sure most of you would not have heard of it. This is called search and rescue. This control center is in ISRO. So what this does is, basically these are commercial beacons. So suppose somebody is going on, a trek to the mountain, or somebody is going deep down in the forest, and they will carry this beacon, which is commercially available. It's a low-cost beacon, and even most of the helicopters and the aircrafts and the ships carry these beacons. So what happens is, when a person is carrying this beacon, and if that person is in distress or there is an aircraft crash, so this beacon gets activated. So once the beacon is activated, the signals go from the beacon to the satellites. This is called a search and rescue beacon, and there are satellites which are carrying the search and rescue transponders. So they will detect this beacon signal, and from the satellite, that distress signal comes to the mission control center in ISRO. That is the place where I work. So then from there you know that, okay, each beacon has an identifier. So you know that this person who's carrying this beacon is in distress, and that information is again dissipated to the recovery team, which is again outside of ISRO. So this is done not just by one organization. There's a consortium of organizations which is actually doing this. And if you look at the region, our entire India and the neighborhood, we have a coverage with the search and rescue beacon. This is called LUT, is the local user terminal that we have at ISRO. And this started in 1990 and it is operational. Recently I heard there was a helicopter crash somewhere near Bombay, and I think within 2 hours or so people were rescued because the signals came to the MCC. Yeah, this is the indigenous or the ISRO-owned navigation system that we have. It's called NAVIC. They're basically a constellation of 7 satellites. We have right now we have 4. We're going to have 3 more up there. But you have all of you and many of you would have done science, and you have 4 variables basically to know your position and time. You need X, Y, Z, and T. So if you have 4 unknowns, you have 4 satellites giving you 4 set of measurements, you will be able to do a minimum position determination. So of course it's not as simple as that. There are so many errors that come up when we start looking at finding the position, because the atmosphere itself can cause errors. There can be multi-path errors. There is different type of attenuation happening on the signals, and the most important is the clock. So if you're away by, your satellites are moving at, let's say, even a nanosecond of error could give you some 30 centimeter error in your position. So the clocks have to be very, very, very precise. So this is some of the challenges with having this navigation satellites and finding the position and velocity from them. So ISRO is also, we have this ground segment for this entire navigation satellites, and we have it in ISRAC in the place where I work, wherein the corrections are applied to the satellites and then we receive signals from the satellite. So this is an animation just to show, how communication can happen between various satellites, and how we have antennas. Let's say that you have an antenna in some other country, and let's say this is Bangalore, and we are having our own ground station antennas here. So if the satellite is going from one place to another place, or if it's going around in the orbit, this antenna communicates to the satellite. We receive something called telemetry from the satellite. That is the data which is coming from the satellite. It will have information about all the systems which are there in the satellite. And then you also send telecommands to the satellite. You can see some green lines going up and down. So these commands will tell the satellite what it's supposed to do. Mostly these satellites are autonomous, but still, if you have to take a picture, let's say I want to take a picture on Bangalore, you have to tell, okay, take a picture on Bangalore. The next day I want to take it on Calcutta. So you have to give that command to the satellite that you need to take a picture here. Or whatever payload it is operating, you need to tell it how to operate. So for that the commands need to go, and this is just an animation of how the commands go to the satellite, and how these satellites, the data collected from the satellite also, the antennas are there at different places, in geographically different places on the earth, but the data also comes to the control center in Bangalore. So that is again through another communication satellite. So this antenna collects the data from the satellite throughout this time, and then gives it to this communication satellite, which again comes to the control center. The control center itself is having some antennas, and when the satellite comes over this location, this antenna will be tracking the satellite. So this is how the planning and the operations for the day-to-day operations go on. Yeah, so a lot of people say, why do I have such good cameras on the earth? In fact, my mobile itself can take good pictures. Why do I need remote sensing satellites? Why do I need to spend so much money, put a satellite in orbit, and then take pictures which are probably which look similar to what I can maybe using aerial aircraft, or nowadays you have these drones, right? And the drone technology is also fast progressing, so I can put cameras on the drones and then send it everywhere and take pictures. So the reason is this. So you can see, if I fly a camera in a balloon, or not only a camera, any payload for that matter. So the region that it can see will be of probably 30 to 40 kilometers. So if I'm looking at from an aircraft, a payload, that payload would probably see a distance of maybe 300 kilometers. But if I'm looking, if I have the same payload on a satellite, because it's at a much higher altitude, it will see a larger area on the Earth. So it could probably see, a circumference of 2,000 kilometers. And if I'm able to see more than 2,000 kilometers as I fly over a country, within 2 days I would be able to see the entire globe. So this is the kind of utility that we get with when we have a satellite, when we fly a payload within a satellite. So basically it's for larger area coverage, and then the track or the orbit of the satellite more or less remains the same. Of course, all of you know about the drag, and there are forces that continuously pull the satellite down, but they are of very small order. And so more or less the track that it follows in orbit will be the same. So that will give a great advantage, because you will be seeing the same position on the Earth from the same position in space. So your illumination conditions also may be the same. So this gives lot of benefit in terms of coverage and in terms of getting repeated cycles of coverage. Yeah, so this is a little bit. I've already spoken about equatorial orbits, why you need polar orbits, why you need inclined orbits, and different shapes of orbits. So yeah, this is probably textbook stuff which you can get everywhere. But what I want to tell you is, if you look at what we are doing today. So if you look at this, we are here, India. So all our low Earth orbits are here up to 900. Some of them can even go up to 1,000, 1,500. You have the geostationary. You have the moon at the distance of 385,000 kilometers, and then you have the Mars. So these are the missions, if you want to pictorially represent in terms of distance that we at ISRO are doing. Yeah, so now we talked about, quickly about the three major components of the space segment or the satellite segment. So one is the satellite itself. The satellite per se itself does not make sense. It cannot go there to space on its own. You need a launch vehicle. So you need the launch vehicle, and then to keep the satellite up there, you need the ground station. So the three important components. We'll just see how ISRO is actually, we have our, we call it as a workhorse of ISRO. We have this PSLV, which carries all these satellites to the low Earth orbit. This is what I just explained. Orbits between 500 to 900 kilometers. And then you have the GSLVs, which take satellite to the geostationary orbit. Now you have this new missions called this GSLV Mark III. I'm sure all of you read about this OneWeb constellation. So OneWeb is again a communication satellite done by Europe. So this GSLV Mark III carried 36 number of OneWeb satellites. This was in November, October, I think, yeah. To space in one go. All these 36 went one go in the GSLV Mark III. So that is how we progressed with time. Lot of developments have happened with the launch vehicles also. Yeah, so what is latest about the rocket technology that we have today? So one is the GSLV Mark III, which is in fact is going to go commercial. We're going to have one more OneWeb launch next year, early next year, which is going to carry another 36 satellites in one shot. So we also have this another smaller rocket called SSLV. So this is going to carry in a very short time. Let's say there's a sudden demand to put a satellite in space. So within 72 hours you're able to assemble and build it. It will carry small satellites quickly. So the advantage is that it can be assembled quickly and it can be done at a very low cost. So this is something that we're going to try out this year end and early next year. Now coming to the third component of what I said. What happens, how do we manage the satellites on the ground? Obviously, though the satellites we say are autonomous, we need to know where they are. We need to track them, right? And we need to get data from them eventually. That's the reason why they are. Apart from the communication satellites, the rest of them need to send some data to the Earth. So for that, we have this host of ground stations which are all around the Earth. You can see ground stations, and these are all owned by ISRO. And we also have our own ground station in Antarctica. I don't know how many of you know. ISRO has its own station in Antarctica. So the advantage of having an Antarctica station is whenever you have a polar orbit, right? Because the Earth goes around and around the poles, this particular station is able to see every orbit. So every orbit this Antarctica station will have a pass on itself. So it's a strategically a very important place, geographically a very important place to have a ground station at the pole, because especially for polar orbits it's useful, because if you have stations on the equator, as the Earth rotates, so and the orbit is there and the Earth rotates, very quickly the station will move away from that orbit and we will not be able to contact the satellite. But if you have a polar station, you will be able to see it every orbit. So that is the advantage. So yeah, this is just, I do invite all of you to come to Bangalore, but just to give a sneak peek into where I work, this is a network control center. So all these antennas that you saw all over the world, they need to be controlled at one place. So you need to tell each station which satellite. You have 27 satellites now, and all these antennas have to be constantly tracking one after the other. It tracks one satellite, the next moment it has to track another satellite. But there should be somebody there to control all these activities. So that entire control is done in a totally automated way. In fact, this entire control center is unmanned. So all these operations are automated, and they happen in the network control center. This is a view of our station in Mauritius. This is in Brunei, this is in Trivandrum, and this is in Lucknow. Yeah, we have different, different sizes of antenna. You basically need different sizes of antenna, because the bigger the antenna, the farther you can track the satellite. So especially for deep space missions, you need to have huge antennas. I'm sure all of you have read about the link budget, right? So the power with which the satellite transmit and the entire thing is budgeted. Like what is the power with which the satellite transmit the data, what is the power that you receive, and how much of it you are able to retrieve from, there's a lot of other noise that is there when you communicate to the satellite. On how you are able to retrieve is all done through a budgeting. So the bigger the antennas, the better you have, a better margin you have, and the farther you can track the satellites. So this is a 32-meter antenna which we have in Bangalore. It's in Bailalu. So this is called a deep space network, and we use this antenna to track missions which are going beyond the Earth's gravitational pull. So the Mars mission, probably missions beyond that also. We have done this we even track missions of other space agencies through our deep space network antenna. So these are the regular antennas, and these are again, if you place them again on the world map, this is how all the ground station antennas look. We don't own many of these stations ourselves, but we collaborate with these stations whenever we have an important mission. So, yeah. Yeah, this is a picture of how our deep space network looks. This is a communication. This is a 32-meter antenna. I'm not sure how many of you can actually imagine the size of 32 meters. It's probably bigger than this room. So 32 meter is that big an antenna which is kept here on this pedestal, and this is the science data center, and this is the complex that you have. You can see that mostly things are barren around it, because you need to have a clear field of view, especially for the passes that are coming just over the horizon. So you cannot have high-rise buildings around the antenna station. Yeah, so this is a glimpse of the mission control center. So all these pictures that you've seen on TV, right? The Mangalyaan and the Chandrayaan, especially during the moon landing and the Mars capture. So these are relayed from this mission control center, and this is how it looks from the inside. This is a conference hall, and this is a dedicated mission control center wherein all these 27 satellites are controlled. Okay, ma'am. Okay, yeah. So let me just let me talk to you about, maybe this is the last. I have many slides. Maybe this is one thing I want to talk to you all about. We are all facing a problem today. So I want to bring it, sensitize all of you about this issue that we have. It's called space debris. So all of us, just imagine all of us move around in Calcutta and Bangalore with our cars, and every time the car breaks down on the street, what happens if you just leave the car, go and get by another car and start driving another car? So this is what is happening in space. So we send rockets and we send satellites, and after their function is over, we just leave them there. So imagine what would happen to your city if you all did it to all your vehicles. Go use them, once they are defunct, leave them there and then buy a new car. So if you look at what happened in 1957, there were only 2 objects that were actually tracked in space. And then when you came to 1992, it became this, and this is 2015. And today we have a capability to track objects which are greater than 10 millimeter. And this is how it looks today. It's a pretty scary picture because we have almost 30,000 particles or objects in space. And this is going to pose a very big problem. So this is going to pose a big problem because for many reasons. So every time the satellite is in orbit, it might actually encounter one of these objects, and then what do you do? So you have to, if you're going and there are a group of people standing, obviously they're going to take a detour. So you need to take a detour, but a detour is not always going to be easy. It's going to come at a cost. So every time you see an object, you probably have to detour. That is if you are tracking all the objects. That is one problem. And if you have not tracked the object, there is a probability of collision. It could damage because the satellites are moving with 7 km per second. There is another object moving with the same velocity, and if they are moving in opposite directions, it can come at a really high speed. So it can cause potentially a lot of damage to your own satellite. So this is one thing. The other thing is, one is the objects. Another is there could be, if you look at what is happening here, on the lower orbit you have this entire cluster of debris sitting, that's the region that I was talking about, and then you have this other geostationary orbit wherein again you have a big clutter. So this is some of the damage that I wanted to show you. This shuttle window, all of you know the shuttle window has to be replaced many times because quite a few times it was hit by debris. And this was a lady who actually found a piece of this Delta II rocket. And the Hubble telescope, so that solar panel was actually damaged by one of these debris. So there's a lot of things actually, this is a worrisome aspect because one thing is there are, every time there's a collision, it not only damages the satellite but it further creates more debris. So every collision probably creates another 50 debris. So each of those 50 debris again has a collision, creates another 50 debris. So it is not only that we lose the satellite, but we're creating more and more debris. So eventually there may not be enough place, and even many times when we launch our rockets, we'll have to reschedule the launch because along the launch trajectory we might find a debris. And you can't do anything about it because if it's a live satellite, probably you can talk to them and one of them moves away. But if it's not a functional satellite, you have to move away. There's no other way. So there are launches getting delayed by a couple of minutes because of the debris. There are frequent maneuvering that we do, but then what is the solution? So there is I just wanted to tell you all students, so we have this committee. So right now we have rules, they're not really space laws, nobody is imposing it on people, but then this group of space agencies come together and then they say, now that whenever we launch a satellite, we need to bring it down after 25 years. Or so, let us say, if it is say, if it's an active satellite, suppose, and whenever you launch the satellite itself, you design for the re-entry, for it to come down to the re-enter the space, re-enter the atmosphere. So now, what else can you do? What are the other methods? I mean, these are some things probably all of you, as you grow up, you will have to deal with the next generation on how to clear this debris. There are so many innovative ways people are thinking about. So, it could be to One is to create extra drag so that it comes down on its own, or maybe have something like a net which will go and grab all the debris and bring it back. And another interesting point when we do this reentry analysis is that there is a point called Nemo Point in the Pacific, wherein when all these satellites are going to be deorbiting, we try to, wherever it's possible, we try to maneuver the satellite so that it enters at the Nemo Point, so that it doesn't cause any potential damage to people living on the Earth. So, yeah. So this is another center which is again a part of ISRAC. It's called Space Situational Awareness, and it's called ISOM actually. So wherein they work not only at this debris, they're also looking at planetary defense. So the threat is not only from debris, the threat could potentially be from near Earth objects like asteroids and other things. So we have a center called Netra, which will be, wherein it will be developing optical telescopes and radars, which will be probably looking and trying to track all these debris, and then it will formulate, for us at the operation center, it will give us, we get alerts, twice a day, saying that these are the objects that probably are coming closer to your satellites. So this information is given by our team at Netra to us all the time. And in fact, what I wanted to tell you is this threats are continuously increasing by the day, and the number of times we do a maneuver to avoid this debris are also increasing by the day. So I think I have a couple of slides on the Mars mission. I think, ma'am, because of paucity of time, I'll stop at it. I'm sure all of you have read, and you must have seen a lot of movies also. I mean, a lot of it is not really true, the Mangalyaan, but then I thought I could speak a few things about Mangalyaan mission itself. But I think maybe I'll just show you the pictures if it's okay.
Yeah, that's fine.
That's fine?
That's fine.
Yeah. So this is another satellite called NISAR. It's called NASA ISRO Synthetic Aperture Radar. I was working on it till last year, till I moved to ISRAC. So the good thing about it is it can detect a 4 millimeter movement in the Earth's tectonic plate. That how it does it is it has a synthetic aperture radar which is constantly looking at the Earth, and any change in it sees, it's able to detect the change, and it's able to detect this tectonic. It does a lot of other things, but this is one thing that people are really looking forward to. So I wanted to explain so this is another very nice mission that I did, and I always like to talk about it because I was a part of this mission. It was the first re-entry mission that ISRO did way back in 2007, and that time there were no newspapers, there was no publicity. ISRO did it silently, but this mission went to space, stayed there for 13 days, and then it did a re-entry, and then we recovered the entire capsule in an integrated way, and we got data till the last moment. So you need to brake, and you need to change the trajectory to re-enter the Earth. So that was, the braking was done, and then to reduce the impact velocity, we have to open parachutes, and then there's a flotation system that opens up when it touches the sea. And these are actual pictures. They're not drawings, but these are actual pictures taken by a helicopter as the satellite was recovered. There's a lot of stories about the satellite. The mission itself, it was very dramatic. Maybe some other time. Maybe you can click it from there if it's faster.
Or maybe show it this side.
This side? Yeah, I wanted to talk a little bit about the Mars mission, and then all of you know why it was so challenging. One is the fact that the Mars mission itself, the trajectory itself, for all of you science students, you're actually leaving the sphere of influence of the Earth. So basically, it is the first time ISRO was doing a mission to go outside of the Earth's gravity, and then the trajectory itself was difficult because designing the trajectory was one thing, And another thing was to, to launch it within a specific window. So we didn't have too much time for this, because when you design a trajectory like this, you have to launch it within, you get this opportunity once in 18 months, and it had to be done. This is because of the constant geometry. And once you actually launched and you design the trajectory, but to know where the satellite is on that path is another challenge. So we call this as navigation. Navigating was not easy because there are so many issues that can come. The radiation, the solar energy itself, it can give a torque on the satellite and deviate the satellite from its natural path. So all these course corrections had to be done, and then we were actually trying to it's more of a rendezvous problem, like I wanted to actually explain to you. So from the time the satellite left the Earth, and all of them are constantly moving, the satellite reaches the Mars, and it had to do a maneuver, and at that accuracy with which it had to reach, or the trajectory, we had to be, we call it as a pillbox. That is the error that we can tolerate. So we had to target a pillbox of 50 kilometers from a distance of 225 million kilometers. So this was the kind of accuracy that was required. And there were so many new techniques that were evolved to do this. We had new methods called differential ranging. The other important thing was the lifetime delay itself. So anything that you like, unlike your low Earth orbits, when you communicate to a satellite which is around Mars, it takes, at the farthest distance, it takes 22 minutes. So when I'm talking to you, you probably hear, if you are having a question answer session, or I'm asking you to do something, you hear it after 25 minutes, and after you do your job and you tell me you're done, I know that after 25 minutes. It's like you can have a good meal in between, two command sessions. So, but how do you deal with such situations? So we had to build a lot of autonomy into the satellite, and then you have this blackout and whiteout, wherein the Mars itself is obscured from the Earth because of the sun. So these are some of the challenges that we had. And talking about mission planning, the one thing that I learned in all my years of experience at ISRO is, irrespective of what you plan and how much ever you plan, there are always situations that you have not really envisaged. There's something new that is going to happen, for which you have to find solutions on the fly. So finding solutions on the fly is one of the very, very key important aspects that we learn, and that is what actually makes the difference between having a success and a failure. So once we had already reached the Martian atmosphere, we found that there was a comet that was coming from the Oort cloud, and we were able to, so the objective was not to take the picture but to actually survive that comet encounter, because this comet leaves a trail of dust behind it. So we had to actually make sure and do maneuvers such that while the comet passed, at that exact time we were on the opposite side of the Mars surface, so that we kind of ducked behind the comet shower, and just as that comet passed, we came out, and then we took some pictures from the backside. So these were some of the pictures. Yeah, we also had some amazing opportunities to look at the moons of Mars. This is the Demos, and this is the Mars, yeah, this picture is also my favorite, because when the Mars orbit insertion happened, everybody said, like, yeah, there was an announcement that okay, ISRO's Mangalyaan had reached Mars, but what is the proof? So we had come up with this idea of taking a picture just as it got inserted, but there were a lot of debates that happened. Seetha madam was also a part of it. People were worried about operating the camera because you're in a new environment, right? And you don't know if something could fail. Why do you want to jeopardize the mission? And do you think it's worth taking a risk? But then it was thoroughly analyzed, and we said absolutely it is safe to take a picture. And this is one of the best opportunities we had, and we had good illumination. So just as the satellite had entered the Martian atmosphere, we had taken this picture, and this was relayed, within 40 minutes we had this picture processed and showed it to people. The proof of the pudding is in eating, right? This is the picture, we have reached Mars. So this is one of the pictures, and yeah, these are some of the pictures taken by the Mars color camera. Mars is also home to many of these volcanoes, and the highest volcanoes in the solar system is on Mars. So you can see some of these. Yeah, this is some of the pictures taken by Chandrayaan 2. I just thought, it will be in. So when we hear about people, satellites doing so many things, and I wanted to show you some of the good pictures that we have from some of our science missions. And yeah, this is again the terrain mapping camera. This is the North Pole region of the moon. And this is, you can see there is a legend here which says it's a crater diameter is almost 5 meters, which it's able to detect. These are some of the boulders taken by the OHRC in the Chandrayaan 2. Yeah, this is some of our remote sensing. This is not a science mission, but it's one of our optical images. You can see how clear it is. This is Perth and this is Mumbai. In fact, this is not even one of the high resolution cameras. This is LIS4 is about 5 meters in resolution. So you can see how we can actually mix and match images from various sensors to create this color image with high resolution. Yeah, this is this UV image. I'm sure most of you have seen it, and Seetha madam will probably explain this better on this 100 million-year-old galaxy. Yeah. Thank you so much. Yeah, I just wanted to end by saying one thing. Do you know which is the next out of the world idea? So it's actually to go out of the world. So, a lot of people, while we're talking of satellites, a lot of people now are talking about commercializing space, not just habitating other planets, but to have such conference and meetings from across various space stations outside in space, go to space for, just for leisure, just on a holiday, maybe for work. So, yeah, so that is the future that all of you are going to see. Thank you so much.
Thank you, madam, for such an informative talk.
National Council for Science Museums for this is being done in collaboration with BITM, and I thank the director of BITM, Mr. Bhatacharjee, who is here with us, the curators, Mr. Rajiv Nath and Dr. Rakesh Majumdar, also for helping us put this event together. It's my pleasure today to introduce the panel, and then I'll get the hell out of this stage because I don't deserve to be here in front of this panel. So let me start by introducing Nandini very briefly, because Nandini has already been introduced to all of you. She is the director of ISRO, deputy director of ISRO. She is in charge of handling various satellite missions right from their planning, execution to operations. And as you've already been told, have a seat anyway, wherever you prefer to, she is deeply involved in all these ISRO missions. There have been movies made about her, there have been documentaries made about her. I'm not going to go into details about this because you already did hear about this. It's a pleasure to introduce Seetha. In fact, I pretty much know everybody on the stage, either from my student days or from my travels to various conferences. Seetha was my teacher, in fact, when I was in ISC. Seetha did her PhD in ISC as well. She is an emeritus scientist at Raman Research Institute, Bangalore. She superannuated as an outstanding scientist from the URA Satellite Application Center in January 2009. After serving in ISRO for more than 39 years. She was earlier the director of the Space Science Program Office at ISRO headquarters and was responsible for ensuring the coordination of all space science activities at ISRO. She is also the principal investigator of the AstroSat mission, the first dedicated space astronomy satellite of India. Her areas of research is in the fields of astronomy, particularly in the domain of variable stars, in the X-ray and optical wavelengths. She has contributed extensively to the development of several space science instruments, which is flown in different Indian space science missions. She has over 80 publications in the field and has guided several PhD students. More importantly, for me personally, for this National Space Science Exhibition, she is also the chair of the National Organizing Committee that is involved in overseeing the outreach for this symposium. And I just simply don't know how she manages to keep cool when I lose it every day. But throughout my life, she has been a source of essentially calm wisdom. She calls me Dandy, my nickname for my student days in ISC. Thank you for being here, Seetha. We have next Devleena Bhatacharjee, a space entrepreneur. Devleena, come on stage. I got introduced to her this year, met her in a couple of conferences. I'm very kicked about the kind of work that her organization is doing. So she is a data scientist. She's with more than 15 years of experience in using data to solve real-world business problems across different domains. Her first data science startup, Vukashan, was a risk intelligence platform for the insurance industry using satellite data. Her second data science startup, Nemo 8, is currently using satellite data along with other sensor data to build profitable, traceable, and sustainable fisheries. She has founded Nemo 8 in 2017 and now works with a team of data scientists, data architects, and GIS analysts. Nemo 8 is Office's product is unique globally and has been recognized by the European Space Agency and the UN World Food Programme for addressing different challenges that are part of their global programs. It also got selected by the ISRO ANIC ARISE program in 2021 to work to build an affordable and effective marine communication system for fishing boats, especially needed during search and rescue operations, and to keep them informed proactively for critical weather conditions. Currently, the numeric team is using ocean development data to explore additional livelihood, enabling technologies and coastal communication for figuring out the distribution of seaweed, which impacts the livelihood in the coastal regions. Devleena speaks extensively about the power of data science in solving global issues, climate change, and food security. And she is, in fact, currently the chairperson of FICI's Fish Tech subcommittee, which helps her to engage further with the sector and build interventions between multiple stakeholders, including fisher folks on the ground. Devleena, welcome to the panel. We have Nikhitha C with us today. Where is Nikhitha? The youngest of our panelists. She's a space entrepreneur and an enthusiast who's a Kalpana Chawla scholar from the International Space University, and a TEDx speaker and a social impact entrepreneur. She started her journey as a student entrepreneur by co-founding the Society for Space Education Research and Development, a non-governmental organization with a mission to open the space frontier to all by promoting space education amongst the community and preparing the young generation for the space revolution that is ongoing. She is the co-founder and CEO of Genex Space, an educational tech startup which works towards providing quality space science education for students worldwide through an extraordinary aerospace curriculum. And she also, in fact, her company is engaged with the capacity building office of ISRO to deliver education to multiple schools around the country and beyond. Welcome, Nikhitha, to the panel. Next, I have Avyarthana Ghosh. Come in, Avyarthana. Have a long connection with her. She was the first batch of students who joined the center that I established, the Center of Excellence in Space Sciences India at ISRO. She's currently working as a scientist with TCS Research. She's an alumni of South Point High School, Kolkata, where she completed her bachelor's in physics from Lady Global College, followed by a BTech and MTech degree from the Institute of Radio Physics and Electronics at Calcutta University, and then she joined CESI ISRO Kolkata for a PhD, where she worked in collaboration with IUCA, where she was placed on deputation to develop the solar ultraviolet imaging telescope, which is flying on board the Aditya L1 space mission. She is one of the few students, PhD students I know, who's outside from the ISRO centers, who has directly helped in building, planning, and developing a space science instrument, which is going to fly on the mission. So, welcome, Avyarthana, to the panel. I also particularly like the fact that she's taken this leap from academia and gone to a private enterprise, TCS Research, because this is where the future really lies in collaborations between academia, between government organizations as well as private players, where we take our understanding and build things in a way that is not always possible to do in working within the confines and sometimes the very inertial rules of government organizations. It's a pleasure to also welcome Shyama on board. Shyama Narendranath has been involved with all the moon missions of India. She currently is the principal investigator of the Class 2 instrument on Chandrayaan-2 mission. She also was involved with the Class 1 instrument on Chandrayaan-1 mission. She is not just an expert on explorations of the moon, but also a planetary scientist with wide interest in understanding not just processes on planets, but also how the environment of planets, for example, the activity of sun, solar wind influences planetary atmospheres, processes on the surface as well as in the near surface layers of planets, which may in fact lead to conditions of habitability or innovation. Shyama, welcome to the panel, and thank you for being with us. Let's see, who am I missing? Anandita I'm saving for the last. Okay, yeah, so we have everybody else other than Anandita? Okay, so Anandita is saying for the last because Anandita is a close colleague. We were students together, although she was much, quite a few years junior to me in English of Science. She's from a department where I used to visit regularly for other personal reasons. My wife is from the same department as she's from, Secretary Political Sciences in English of Science. So Anandita is a behavioral biologist, but I'll explain why she is here. From the Department of Biological Sciences, University of Science Education and Research Program. She is engaged in studying the behavioral ecology and cognition abilities of dogs using free-ranging stray dogs in India as a model system. She is particularly interested in understanding the evolution of the dog-human relationship. She is the recipient of the INSA Young Scientist Award, the SERB Women Excellence Award, the IAP Young Scientist Award, and the Janaki Ammal National Women Bioscientist Award in the Young category in the year 2021. She was involved in the co-founding of the Indian National Young Academy of Sciences (INYAS) in 2014 and served as its chairperson for the first 3 years. She is a member of the Global Young Academy since 2016, where she served as a co-chair from 2020 to 2021. Anandita believes the responsibility of scientists in engaging with the society and is actively engaged in various science outreach activities. In fact, she is the Associate Dean of International Relations and Outreach at ISRO Kolkata. More importantly, Anandita and her husband, Oyon, who is my colleague in the physics department, also runs a theatre group called Ghosh. And this week, Anandita is juggling the role of a mother with 2 kids, probably writing exams, her engagements at ISRO Kolkata, and she did 2 plays this week in Koldani at a theatre festival. She has been involved in various panels discussing the challenges and opportunities faced by women scientists, particularly at INYAS and at various global forums. And I could not think of a better person than Anandita to compare to this panel. I will quickly get out of the way, but before I do, let me just say that these are some extraordinary people that you have accomplished in their own professional domains on the stage. And I'm not using the word extraordinary women very consciously. And I hope that someday I'll have the privilege of introducing a better panel, which I think is going to be quite a challenge. But I hope that we can get there someday. Anandita, say please.
Thank you, Devleena. It's my honor and privilege to host this session of stellar colleagues from the space sciences. So I will not hold the stage for long. I will welcome them and ask them to speak about their journeys. So this panel is about hearing about the journeys of some extraordinary scientists and hoping that some of the students here in the audience will be inspired to take up such roles for our society in the future. So let me begin by inviting Shyama to speak first. So how we'll do it is each of them will speak for a few minutes, 7 to 8 minutes, and then after everyone has spoken, we can take questions from the audience. You can raise your hands and somebody will take a mic to you. You can ask your question for the panelists to answer. Shyama, go to you.
I'm really very very happy to be here and indeed privileged to be. I'm so happy to see you all. I have. Yeah. So very delighted to see all of you here. I have two kids at home, not really kids. One really grown up and another in sixth standard. So I can really relate to how you are feeling because I constantly hear from them. So I come from Kerala. There's a small town, Palakkad, and when I was growing up, I had very little exposure to space sciences or any of that you are actually have more exposed to. And it was those days when the internet also was not so really good. And one thing I wanted to really stress upon you, because I hear from a lot of children like, actually you're not clear what to do in future, right? You actually don't know which subject you like. So sometimes it happens that if you score high in some subject, you would think that's what I want to do. So I never thought I'll do physics. Actually, throughout my whole education, physics was the subject I had lowest marks in. But later on, I went on to do a PhD in physics. But if I look at my school days, I think it's more like I really didn't understand at those times. So what you right now have is more, I think, influenced by your teachers and what you read, or at home what you hear about, right? So sometime I wanted to be a writer. I was very interested in English. I think up to 12th I wanted to be a writer, wanted to take literature. Then I used to dance, and still I do, but I wanted to be a dancer after 10th standard. I wanted to go to Kalakshetra. But again, there were restrictions because dancer was not something my family wanted to look forward to. So one point I wanted to stress out is like, you know, at this point maybe you really don't, you may not be good at something just because you're not exposed to it in the right way. So until you experience it, so go out and read about it, do something, and really start enjoying the subject. Only then you really know what is the path you've taken. So this is the right time to explore and go about it. Personal journey, since you asked about it, so I did till my masters I did in Kerala. Then I got married and I came to Bangalore. I never had any thought of, I just wanted to just a job, maybe that's all, because I wanted to earn myself. And I should say my first job as soon as I got married and came to Bangalore was I was really going around Bangalore looking for something to do, because I just had an MSc in physics, and one of these coaching centers employed me to write question papers and also the answers, and for every question paper I get 500 rupees, also have to correct when they came. And that's where I found actually if I correct very strictly, they're telling you no, actually don't go down on the marks, because they want to show to the parents that your coaching centers are actually bringing out good students. So if I do a lot of very hard corrections, they end up getting low marks, so that's what they don't want that. So I think I was not very good at that job at all. I did go to a lot of schools, did interviews. I remember even crying so much that I didn't get in a school. I wanted to say this, it's a one high school in Bangalore I went to. And the first question they asked, I didn't answer properly. And you know what it was? They said, define physics. And I said, all sorts of things. It's about learning about the whole thing. But they said the simple answer was, it's a study of energy and matter. And I should have known. Anyway, at some point I was lucky enough to get into ISRO as a junior research fellow initially. And Dr. Seetha was the person I remember in that interview panel, because she was all smiling. And I just went in, I remember only her. She was the only woman in that panel. So the rest of them were all gents. My future guide was also there, but actually I don't remember him at all in that panel. She was the only person, and I was so relieved seeing her. Because, this is there actually. When you get in and you see a lot of very senior gents sitting, you are a little nervous, and then you see a smiling lady at one end, I'm relieved. So I think I did that reasonably well, and at least I got through. So that was actually when I started enjoying doing physics, because I was fortunate to have very good people I can work with, like her and my thesis supervisor, Shyama. So that was when I really started doing this well, and eventually earned a PhD, and I work now in the same group called the Space Astronomy group. So all this happened actually after I got married, and even before I registered for PhD, I had my daughter. So because I have girl students now who are always in this stage, because when you start a research, you're like committing for 5 to 6 years, right? Where you really need to focus, you have to write papers. So always in practical terms, this is in your mind. Like your parents will be asking you, how are you going to have like 5 to 6 years without, marriage? And because at least in our society, there are privileged people, but if you come down to most of the population thinks this is the age that you need to settle down. Not so much for the boys, still have a little time, but at least girls, this is what they think you should really be settling down. And then you're saying that you want to do this 5 to 6 years without any of these. In that way, it is a little difficult at that point. And also since you are teenagers, I could see my daughters as well. One thing I want to do is I want to be independent, I want to stand on my legs, which is very good, and that's what gives you all the drive. But at some point you realize that the interdependence is really needed, because what we are today is actually because of so many men and women out there who have helped you at every stage in life, whether it's been your parents. So I don't think it's anything wrong to really reach out to them, because that is where you can put in all your effort, because they are there. Because there is no such absolute independence that you can gain being in a society, being with friends. So if you do have parents, you do have friends, colleagues who really help you, whether you consciously or unconsciously, that environment is really needed for you to be. So, don't just feel that I need to be without anybody's help. All of them are there, and that's how you grow in life. So for me, it was a blessing that I had my parents to take care of my children all the time. Of course, my husband was also supportive, but really, I would say my parents were one of the prime reasons I could go and do PhD and not really worry about all the things at home. And of course the office environment or the yoga guide is a main factor, because that connection is very important. You want to do a work together, you have to be in the same wavelength, you put in all the sincerity and effort. That comfort zone is very important. So overall, yes, being a woman, it takes a little more extra effort to get there. But I think it is actually finally the attitude of the society which is gradually improving, that how that society is providing you this environment is what actually leads us there. So our motivation is important, this is important, but then where you are and how you use that interconnection with people is really what gets you there. At least I owe it to all those who I've worked with, and in my career, primarily to my guide, my family for being here, and all the colleagues. Yeah. Thanks.
Okay, thank you, Shyama. I think she began this discussion on a very nice note. And these are really questions that young girls mostly face all the time. I think all of us have gone through a stage like this, so I can completely relate to this that you spoke about. Let me shift gears a bit and call upon Devleena.
Can you please go and sit there?
We have two space entrepreneurs with us today, so let's hear what it takes to be a space entrepreneur from Devleena now.
Excuse
me, you have to clear this side.
Hello?
Boys,
Yeah,
please make it fast.
Okay, so there is a shift in the crowd.
You are blocking the camera, come on,
wait for a few minutes for them to settle down.
Please make it
Go. Put your heads down.
Words on that side. Please make face and leave. Please mind your step.
I think we can fairly start. So, well, hello everybody, and thanks to Dr. Devleena for really suggesting this panel when we met in Chennai, and it's a privilege and honor to really be here. Frankly speaking, I've never been non-virtual women in space panel. It's the first time. Everything that has happened in the last 2 years has mostly been virtual. I think Nikhitha organized a women in space panel, but all from the comforts of your living room and did not really feel real. So, but it's really an honor to be here with amongst all this eminent scientists, and I'm feeling a bit of an imposter because I'm not really GIS trained. So I'll come to my introductions later, but first of all, I belong to Kolkata. I'm born and raised here. I left Calcutta soon after my class 12. So I'm very curious to know who the schools are. I mean, which schools are we here? So anybody from this side of the group, which school is this? I did not hear anything. Oh wow. Okay. Okay, great. Madhavi, Birla, Shishu Bihar. Okay. The yellow caps. One of you.
Holy Palace Multipurpose Institute.
Thank you so much. What about the ones in the back? One person, please. Okay, great. Thank you so much. Oh, sorry. The Queen of the Missions. Yeah, we had some representation from your school yesterday. Great. So, all right. So, I think everybody is talking about our general foray into this space sciences and how we all got started. Mine is a bit different. As I was saying, I'm not really GIS trained, and soon after I left Calcutta, I was in Lurdo House. After that, I left Calcutta. I did my graduation and post-graduation in Bangalore, BSc and MCA. Then I was very we had to take a 6 months internship soon after my masters, and I changed the 6 months to a year. Somehow got that opportunity to do a 1 year of internship in the Indian Space ISC, Institute of Science, sorry. But what really that gave me is that in the entire college, and I'm not really the very studious kind of a student. I participate in all the college functions. Somehow managed to get the distinction in all of it, but mostly my interest has been outside the classroom. But so the IISc tenure of 1 year and the thing about working in academic environment where everybody is deep down researching and should see their volumes and volumes of documentation and the really meditative way of approaching a subject was very essential for me at least, getting think that how research is important for developing anything or building anything that is innovative and that is outside your current everyday life, and so or something that is something that you are developing as a concept and you have to really go through a structured method of research. So that ISC really gave me that, though my contribution to the entire department was very, very tiny and fragile, but I think the entire discipline of being in a research-based institute was vital for me. Somehow did not continue, it was just an internship, and then went into doing my, I joined a corporate firm, and the first, spent almost 9.5 years in a corporate firm working with data sciences. Started from a programmer onto
architectural design and business intelligence and all of it. Fell in love with the analysis of data and used to meddle with a lot of data. So we had a lot of different projects. We had a project on telecom, we had a project, sometimes we have a project on logistics, sometimes we have a project on even satellite communication and Inmarsat. So generally kind of fell in love with the fact that, and back in the day we did not have this fancy data science, applications and interfaces and softwares and model training. It was very, very plain PL SQL and, large procedures and Perl programming and all of it. Any which ways, long story short, the corporate, being part of the corporate environment gave me a sense of what all can be done from the application perspective and the fact that how can you use data for various kinds of applications. But all the applications as typical corporate companies and and they are doing it for their own business reasons they're building was something I want to explore beyond that, beyond the typical urban applications. So in 2015, I started my own startup. Again, I was based out of Bangalore. I have never had an MBA. I've always been to a technical degree, MCA and BSc, Masters, computer science, and very, very technical. But so my first startup, I really realized that it's of course we're innovating something, we're building something new, we're applying data sciences, we had to model weather data and space data and all of it. But there is, if you're shifting from being an entrepreneur to a business owner, you'll have to really understand the business case. Who's going to pay for you? Are you building something that is a real application in the world? So yeah, so those were my learning ropes. First 1.5 years. The startup, we did some successful pilot projects, but we did not really see revenue per se. We learned a lot, all in the hard way. We did not bring any money to the table. All my saved up, savings were gone in really building something that did not really meet customer demands in India. But that was a good learning for me to realize what's my next step. My next step, if I have to really continue as an entrepreneur, I want to go back to the corporate world. What do I need to do? I need to really understand whom I'm serving. I mean, entrepreneurship comes with challenges of being relevant in today's ecosystem, being able to serve a problem of a certain community, being able to deliver them values, and values should grow over time, and being able to meet the competition or address competition findings and be competitive and being having own USP and all of it. So since then, since 2017 rather, I started my own startup called Numerate. Again, there was no money in the bank. We had to bring money to the table, doing all kinds of data analysis as a service, which is not really my long-term plan. But of course, you do various kinds of jobs to really, get the first initial. We call it bootstrapping, as in not taking funding from investors or not from friends and family, but kind of getting your own money from clients and then building from it. So we completely bootstrapped. And then in 2018-19, we were again GIS. As I said, I'm not really trained in GIS, but space data has always been my interest. I have had the privilege of working with a couple of the space sciences project in a corporate, so kind of got an idea of what all possibilities there. And GIS in around 2015-16, we're still developing a lot of applications of agriculture in GIS in India. A lot of giving, all of them will know it more than me, the application of your, how do you say, how well a land is tilted, how do you really help a farmer with advisories, when to grow what crop, how to advise the bank saying that who's giving farmer loans. So all of that has already started. And we got a grant through one of the grants of the European Space Agency, where we were supposed to develop where the entire thing was about working on coastal disaster management. How do you use space sciences to build a disaster management application? Not that there is no dearth of it. There are all this disaster management department has been using space sciences for the longest time. But how can you really improvise? What you can build on the top of that?
So the entire, we kind of looked at what is available, existing, and then we realized that, when any kinds of disaster happens, all of you are, I'm sure, the most users of social media platforms than the rest of us in the panel here. So you realize how Twitters or how Instagrams or any such social media platforms are used in any kind of spreading the messages. So what we realized that in such disaster situations, a lot of use of Twitter was coming in, but nobody was tracking that data, right? So we built a kind of a pilot that overlays the Twitter feed on satellite data. Like, for example, we said, okay, the direction of the path of the cyclone and how even the Twitter feed, the ask for rescue and search and rescue is moving. So long story short, that was an interesting project with us. We did a dashboard on it along with a couple of other companies called SatSure, and then we presented, and then we kind of continued that finding, and we had to submit a report of 10 years to ESA saying that what are our findings of 10 years, patterns of disaster risk for coastal communities, where we realized that, and where this kind of came to us, and where research is very important, as I say, is that and back then we had a very a good team of GIS researchers in my team, where we realized that if you really study the climate change, and all of you must be hearing the word or even studying about it, when you really analyze the climate change and the impact of climate change on coastal ecosystems, there are various impacts of climate change, right? But when you really study and then you do a risk analysis of it and say which community or which part of the world has been affected the most for when it comes to coastal flooding, the community that came out, on the top of the various bubble jars that we created are the small-scale fisheries community. And this small-scale fishing community is 800 million in the entire universe. And they generate a revenue which amounts to 3 billion. So they have a very large economic impact. And so generally, what became very apparent to us is that this community needs help. And when you look at the mainstream dialogue, a lot of the satellite with advisories, interventions, government help, programs are all directed towards an agri part of the community, which are mostly farmers, land-based. And very little is being done, and this is not only India, global, because selected by the United Nations World Food Program that helped us validate the case on a global platform, and we realized 67 countries across the world has the same problem. You talk about the entire Africa coast, you talk about the Latin America coast, you talk about coastal, your Oceania countries, all of them have similar kind of problem, and even Southeast Asia, right? So we realize it's a big enough problem, and fishing communities need help. Also not only because of their livelihood, and not only because of their food security, but the fact that oceans at large, and all of you must be knowing it, that they're warming up. Oceans are warming up, there are ocean acidification is happening, there's a lot of problems with ocean and such. A lot of overfishing is killing their, the marine, biodiversity and all of that. So oceans as a subject matter needed attention. The community that is attached to the oceans the most needed attention. So for us it was a win-win, and of course we had to do the next 6 to 7 months, even a year, up to understanding if there's a business model for all of it. But yeah, so we that's the reason we kind of jumped straight into building what we are building today. And as of today, fast forward 2022, we have basically we have an app which provides advisories to fishing communities, and there is INCOIS is department within ISRO that has been doing it in their own way for the longest time, and we do have a dialogue with INCOIS officials. And but where we come in as entrepreneurs or small teams is that we can go to the rural community, we stay with them, we learn with them, we do the various kind of ground validation, and we kind of added on the overall a different stack of services as well. So it's not only helping them get fish, or not only helping them know about the weather, but we also help them market access, like how do you sell your fish, how do you get your sustainable gears, how do you get your finance and insurance. So it's a stack, full stack. But as of today, we have also realized that helping small-scale fisheries to just fish is not going to help, or not going to cut the cake, because fisheries is a dwindling business, especially marine fisheries, and with the entire climate change, with monsoons extending, and with fishes drying up in the sea, we had to look for additional livelihood. where we have started using space data or using space data for analyzing seaweed. I don't know how many of you know about seaweed, but it's a new crop that grows right out of the ocean, and it provides an additional livelihood source for fishing communities. So yeah, so primarily I'm a data scientist. I have a complete tech background, but my team consists of marine biologists. My team consists of deep down marine scientists, various cultivation engineers, process engineers, and all of it. And we have built together something that is using space data, using satellite data to addressing problems and addressing issues of grassroots level communities, and where we are being able to address a lot of SDGs. Anybody knows about SDG here? SDG? No, not you, sir. I'm looking for somebody from the school. SDGs? Yes? Good.
Sustainable Development Goals.
Perfect. So, okay. Anybody else who what are Sustainable Development Goals? And who created them, by the way? Which body, government body, or it's UN, United Nations Sustainable Development Goals, that are basically created to address the biggest global challenges in the world. So the SDG 2, which is basically saying addressing hunger. There's SDG 14, that is life underwater, that talks about marine health. That I'm just touching on the ones that we address. There's SDGs for education, there's SDGs for women empowerment, there's SDGs for responsible consumption, there's SDGs for climate action and all of it. So do your homework, go back and look them up. All this, this map into various impact that we not only, every companies look to achieve, and it's very, very vital as of today, because the entire planet is moving towards climate consciousness. So whatever you're doing now, what kind of food ecosystems we are using, what kind of food supplies we are supporting, what kind of transportations we are using, what kind of logistics we are using, all of that has come under a scanner of the climate, right? So how much is the greenhouse gas and all of it. So that's something that I think as a community we can help, and especially space sciences really, really helps there to really monitor, to really measure. And that's where I think, if you are interested in space sciences, that's one of the applications I would really recommend to look on. But a lot about me. I'm going to pass the mic and let the other eminent speakers speak. Thank you so much.
So that was an interesting set of experiences that we heard about. And on the note that Devleena ended, the SDGs, just to also inform you, United Nations has declared this year as the International Year of Basic Sciences for Sustainable Development. So why and how we can use basic sciences for attaining the SDGs. So I will now ask Nandini to speak, talking about basic sciences and research about her journey.
Hello again. I talked a lot about satellite data. So I'll be brief. Both my parents are from the science background. My mother is a mathematics lecturer, and my father is an engineer from bureaucrat. I think, like many of you, I was also, I was constantly, pushed by them to do well, and I was one of those kids. It was not all studies and throughout my life. I did multiple things, and I was not the best, and I was never a topper throughout. But then there was always this interest in my mind. I remember when we were kids, my parents, my father especially, would explain the basic concepts of physics. How does the water go up to the overhead tank? When you join a pump, like very basic things, facts of life, he would explain in terms of physics. But I think, though it didn't really show up in terms of textbook knowledge, but we all had, growing up, we had our basics really strong, and he would show us about, in fact, at a very young age, we could recognize all the constellations, Saptarishi Mandala. So we were lucky to have a good background growing up. Coming to ISRO, I joined way back in 1996. That was actually my first job. Especially the group that I joined, it had only 1 or 2 women. It was the managers at that point of time, they didn't want to take women at all. So that was more because in mission operations, you need to work longer hours and sometimes continue throughout the day and probably stay for days at work because these satellites, like all of us have emergencies, the satellites can also have emergencies at any point of time. Like it could be in the middle of the night, or it could be on a Sunday when you're watching a movie, you get a call from office and say there's some problem and you need to go. So this was one situation, but then they were like pretty hesitant to take women at that point of time. But somehow we went in. At that point of time, my boss, he was one very iconic person, Dr. S.K. Shivkumar. He actually, he kind of understood and probably realized the potential, and eventually we got to work in some of the very good projects. And 2003, for the first time I was designated a spacecraft operations manager. I had a 2-year-old at home. And so something that was actually against women those days, like they can't come to work in the middle of the night, that actually became our strength. And today I can tell you that, especially in the mission group where I used to work till last year, most of the key designations are held by women. And I should also tell you that the organization has a kind of trust, right? That if you give this job to her, she's going to put in her best. So we built that kind of trust. And today there are a lot of men and women. I mean, this is not just for the women, but even for the boys, young boys. You need to build that trust and in the place you work. So whenever you're given a job, do it to your best capabilities. So this is one thing. And of course, every life is not always easy, like both for the men and the women and the young boys. It's not always as simple as people say, right? You work hard and everything comes work your way. It's not really so. So yeah, but then it's all about keeping up your interest and being persistent, and that's important to be persistent. Never let things, small issues here and there affect you in any way. I want to tell you one incident. In fact, I do tell this story very often. One of those days when I could not, I had to take my 4-year-old to work. And so we were actually downloading some important satellite data in the night. It was a operation that had to be done only in the night time. It was like the satellite was dumping some data, and unfortunately for me at home, there was no one to take care of her. And my husband was not in station. And usually, whenever we have a launch, my boss used to always crack the joke with me, like how we trigger backup systems in work, and for launches, I used to trigger the backup support system at home while my in-laws' parents stay with me. Even my brother, who was in medical college, he used to come and babysit many times. So that particular day, there was nobody, so I had to take her to work. And then, like she was saying, why do you want to go to office in the night? And I said, no, there's an important operation, and what do you want to do? Then I said, no, we actually command the satellite, we talk to the satellite, and the satellite will send some data and we'll analyze it. So then she said, oh my God, Ma, what a great concern. Won't it be very cold on the terrace? Because if you have to talk to the satellite, you have to go to the terrace. So then that night, even though she was a 4-year-old, I took her around. I showed her the ground station. The same pictures that I showed you, we actually took her to the ground station. Then I showed her the networking concept and how the satellite, the data actually, we necessarily. But what I want to tell you is it actually triggered a lot of interest in her. She always wanted to be an astronaut, but now she's landed being a doctor. But she actually follows everything that ISRO does, and especially during the Mangalyaan, I noticed that all young people, she used to update her WhatsApp status with whatever was happening in the mission. So, what I'm trying to say is lectures like this, when you hear, it kind of impacts you, and if whatever interest it generates in you, please pursue it further. And if you really like something, go back and, it's not that you can learn everything when you hear somebody speak, but then go back, research on it, and try to see if that is your area of interest, and that is what really triggers you and interests you. So whatever you do, life always, you have three choices, right? You can give in, give up, or give it all that you have. And whatever you are is like what you give to the system. So all the very best, and thank you so much.
Thank you, Nandini. I will now move on to Avyarthana.
Hello everyone. Yeah, so I am from Kolkata. I did my schooling from South Point School first and then South Point High School. So initially, before I got introduced to physical sciences or life sciences, we were introduced to history and geography. So the point is, my first wish was to become an Indologist who is going to be an archaeologist who is going to excavate sites of the Indus Valley civilization. So from there, it's like my mom used to take very good care of my mathematics skills, but my initial interest was history and geography, and those two still remain my favorite subjects. From there, I started doing physical sciences and everything when we were in 7th standard, and one of the best chapters, my favorite chapters that time, was gravitation. But it so happens that now I started working on space platforms which have to escape gravity. So that was my favorite chapter at that point. And when I think we were in 7th standard or 8th standard, that time internet was not there, so 7th standard or 8th standard, we came across newspaper stories, and in school teachers were telling us about Kalpana Chawla, late Kalpana Chawla. So that time it was actually, to be honest, it was the first exposure for me to know about, for many people of our generation in those years, it was the first experience of, going out, like some Indian girl can go out in space. There are space missions, there are people staying in international space stations kind of experience. Like we first were exposed to that kind of a story, which was a dream story for all people of my age at that time. And then from there, I remember, I think soon after school or something, I went to Jaisalmer. And that was for the first time when I saw a clear sky full of stars. Because Kolkata is heavily light polluted. And of course, regular pollution, smoke pollution is always there. It's most of the time it is cloudy. So for the first time when I had went to Jaisalmer with my parents, I first time saw sky full of stars. And then it kind of happened that, okay, so I wanted to work on stars, and at the same time, space missions were something that I wanted to work on, starting from Kalpana Chawla time. Yes, initial thing was we all want to become astronauts, but then we knew that so many people can't create space debris. So yeah, I settled for this. Debris in the sense like we go there, we can't have a station there. And then I started doing my bachelor's and then my master's. And it was a very good experience that time. I really enjoyed my bachelor's and master's degrees. My master's specialization was in space communication and technology, and it was really nice doing that curriculum. For my master's dissertation, I actually went ahead myself and I had applied to National Remote Sensing Center in Hyderabad, which was not a part, I was not deputed from my institute or anything. I had applied on my own and I went there. And from there I started working, I developed some programming skills and everything. I developed an interest of self-teaching myself programming skills. and that was one of the coming from that background of engineering. I think that was one of the reasons why I got selected by SESI interview panel people. So yeah, people who were applying, who were appearing at that interview with me, they were all physics MScs and with very good net scores and everything, whereas I just had a gate score, that's it. So I joined SESI, and from there I went to IUCA for my PhD on solar ultraviolet imaging telescope, which was a dream come true in some sense. If not me, my instrument is going to space. I'm hoping it will go. So, and it is going to work successfully. So there in IUCA, I had a great time. Like, it had its own challenges, of course, because doing a PhD is never easy. A lot of things, work-related challenges come, and it not only challenges your problem-solving capabilities, but it overall develops your personality. There are lots of things, lots of situations that you have to handle. And there was one situation, like I'll agree with Shyama ma'am, that there was one situation where we had this suit PDR, and I had come to this ISRO URSC headquarters where I was giving a talk on the design plans that I have made. And it was a room full of, again, men who were higher in power and of course aged, who were elder to me, and they had more, position-wise also they were higher. And there was one lady with a smiling face, Seetha ma'am. That time she was actually the project director of Aditya mission. So I remember she asked me 2 questions also. SPL director, right? And yeah, so sitting there was only one lady. And I remember many of the times when I was talking, I was looking at her face to give my answers. So from there, but I will be very honest, I have always found support in my male colleagues also, starting from my parents. They have been very disciplined, but they have always given me the liberty to chase my dreams. And they have always, I'm definitely sure that questions have come regarding my marriage and other things from society, because people do ask at some point. So my parents have been very supportive, and they have protected me from the society's questions in some sense. And then my teachers, I have come from a heavily co-ed school, but with a boys majority. But my teachers have never looked down upon the girls as we are incapable of doing something. No. Then I came to my PhD and my postdoc phase, where I worked with ISRO colleagues. I have had meetings where I was the only female, including with foreign delegates, where I was the only lady or girl. But I have always found respect that they have given me. There are always, like, I have heard about stories where things are not that good, but I have always found support in all my colleagues and teachers and family, including the Gandu here. So after doing my postdoc, after doing my PhD, I moved to ISRO iSight, which is in Bangalore, for alignment and assembly of that instrument, which is going to be on board Aditya L1 mission. And that was again a dream come true. I was the only woman for this particular project who was in a clean room working on the instrument with maybe 6 boys. And I was there with 2 layers of clean room jackets, where nothing except my specs. I generally wear specs, so that is visible. And that is when we used to stand in the mirror and we realized that maybe height-wise I used to be a bit shorter than most of the guys were. But apart from that, we are same. In the mirror, we are same, and we are doing the same thing. And we have to deliver equally. We can't just be, I can't be saying that I am a girl, so I'll do less. I think there were situations also where we were asked that if we could work, like girls could work at night in the labs. And the CISF people there had said that it is not possible unless you have a female colleague with you. So there were people from iSight who used to stay back, the scientists there, ladies, 1 or 2 of them used to stay back just for us to work, because we were deputed there. So it was a very interesting journey, and from there now I have moved into industry, which is, of course, I'm trying to bridge the gap between academia and industry, because whatever I've learned from academia, whatever kind of experiences I had, I want to merge them, club them with whatever technology, whatever industry has to offer. Similar questions I had faced when I moved from BSc Physics to engineering. So there also I tried to club technology with science, and now I'm trying to club larger things like academia with industry, and I'm hoping that I will be largely successful in future, but only time will tell. I had a lot of fun, of course, while I was doing my PhD. I mean, I've traveled far and wide and done things like I've trekked up an active volcano when it was billowing smoke, which my mother doesn't approve of sitting there. So I had a lot of fun, but I knew that just as I'm having fun like men do, because there were men who were mostly doing that kind of treks, just as I was having fun there with them doing all that stuff, I had to represent my women community in work also. So I have taken that as a equal footing at all times. I have heard about stories, and I have been vigilant of situations where I could be facing negative situations, but thankfully everybody that I have faced, yes, everybody I have faced, I want to recall before making that statement, but yes, mostly I have found support and respect from all of them. And I have realized one thing, it might sound like a philosophical statement, but you can't, whatever challenges life throws at us for our daily needs to everything, if men are the swords, then women are the shields. You can't go to a war with a sword in hand. You have to have a shield also to protect yourself. So we are complementary in nature. Nature has made us in that way that we complement each other. Our intellect, ways of working, perseverance, all adds to the dynamics of the work that we do. Some people say that women are more patient with situations in life, which maybe other people, like senior people, can comment, even from the perspective of life. Yes, they are, but at the same time, it's a complementary thing. Sometimes we even find men who are more patient. Like my husband is more patient than I am. Let's be very honest. He has been more patient with me and my work-related frustrations over the last 7 years than I have been. So yes, my husband has been a constant support, even as we were friends. Like I got married this year itself. Before that, for 7 years, he has been tolerating all my work-related frustrations. My parents, they have supported me at all points. They have been very disciplined. They have set strict rules for me during my teenage years and later on also. But they have never stopped me from chasing my dreams. Same with my teachers. I am really indebted to every one of them who have been my support system. Thank you.
Thank you, Avyarthana. So, Avyarthana started talking about Kalpana Chawla. So, I am happy to now call for Nikhitha, our Kalpana Chawla scholar, to speak about her journey.
Thank you very much. So, I've been hearing all of your stories, and I feel even if I'm worth to sit here, I said this to Professor Devleena also. So I'm Nikhitha, and I was born and grew up in Bangalore to an extent that I wanted to study more and more, and my parents told me, no, you can't go out of Bangalore, right? So I was restricted to Bangalore. As a child, I wanted to be a pilot because my house is very close to the airport in Bangalore, the old airport, and I could literally see a plane take off, landing. Though I had never been inside, seeing was so nice. I wanted to become a pilot. This was in grade 3, right? And then that interest was there with me till 12th standard. That okay, after 12th I still knew that I want to become a pilot. When in 12th I started looking, okay, what should I do, right? Because I have to apply, and then I got to know that I'm short, right? Like I'm short in height, and then like I got to know that it is not possible. And then I had to quickly make a decision, okay, what do I do next? I was like, okay, if I don't fly a plane, it's fine. Let me learn about all these aeroplanes, how do they work and all of it. That's when I took a decision, okay, let me do engineering, right? Aeronautical engineering. And then I started preparing for that. I was asked, I heard from you like how everyone supported, but nothing was. No, I had teachers, my teachers asking me, like, everyone asked, what do you want to become? And that was asked in a group of people like this. And I said aeronautical. The teacher laughed and said, do you even know the spelling of it? I'm like, what is the relation between spelling and what you want to become? I just wrote it and I left with tears. So that experience I've had. And coming to my background, again, we heard your background. That was not on my case. My dad was a tailor, my mom was a teacher. I was, again, good at everything. I was the topper. Every grade you take, any class, music, dance, sports, anything and everything, I was the first. I was the winner. I'll make sure I'm the winner. Even be it in terms of class leader, I make sure I take the leadership role. Till the extent that I was a school leader. So I was very good in taking leadership. I always wanted to make sure that, I want to do it in my way and I apply all of those. And I think that helped me to do what I'm doing today. Because I'll tell you again. So yeah, I decided on aeronautical engineering and then I was applying for colleges. Luckily, I got a university which was providing not just aeronautical but a course called as aerospace, right? Wherein you learn about aeroplanes as well as rockets and satellites and all. That was like, oh, this is very exciting. Again, we have heard stories of Kalpana Chawla, the rockets and all of it. So yeah, that made me apply for that course and I got it in that university because I had score. I had all the percentage that they wanted and I went on to study. I was studying really well again there. Again, like my background has affected me very badly, okay? Like first year of my engineering, I was the topper and the university selected few students to go for a US trip, probably some conference. My name was on the list. They gave me 2 days of time saying I wanted to bring these things. I went back to home and I said I have all this except one thing and I want it in 2 days. I don't know what you'll do. I said my mom I need it in 2 days and that was passport. So my family didn't know that there is something called passport as well. So when I got to know that it takes 44 or 40 days, 2 days I didn't eat food, didn't speak to anyone. So that was the condition. But yeah, I went on to study thinking there would be more opportunities. Fast forward third year of aerospace engineering, I used to be a student who attends these type of conferences. Just go, right? Don't tell my mom, just keep attending programs because she wouldn't allow me to step out of the house, go to school, go to college, come back to home. That was me. At the same time, I was also teaching. I was taking tuitions till 10th for no money. After 10th, I started charging for my students. So that used to be my income, source of income, from literally 11th grade itself. So 11th till engineering I used to teach, so I had to go back home and go teach 2-3 students to their homes, come back and then study. So no outing stuff. But yes, every now and then I used to go attend these conferences, learn and all of it. And then I met my partner, wherein again he had this interest towards space and learning and all of it. So we formed a group of people who were interested in space, and all we did was just go to different schools and talk about it. Because in engineering, while I was studying engineering, let me ask this question. How many of you like hear stars and planets and all of it? How many of you want to study that, like want to get into that domain, right? How many of you know what should you study to do? What should you study in order to study that? Like what course to take? One hand. So the hands came down. This is what exactly happened among my friends. Most of my friends who took aerospace engineering thought that they would study about stars and planets, and they were in engineering. What we were learning in engineering was totally different. They lost interest, and then I can tell you today in a class of 60, probably 3-4 are in the space sector. Rest all are doing some random thing. But till 12th, they were like so interested, so passionate about this. But after that, they lost interest. And that's something that made me start, as I said, the SSCRT. Society for Space Education, Research and Development. What we used to do is every weekend just go to different schools, different colleges, say what is space, what are the different things that are there in space, how should you perceive if you're interested in it, right? That's what we were doing in my last year of engineering. There was one subject, and it was the first day I went late, and that subject was entrepreneurship. I went late. As soon as I entered class, again, I was very good student, so if I'm late also teacher would welcome. That was my thing in the college. So as soon as I entered, everyone were like, "Ma'am, this is her, right?" And I'm like, "Why is everyone pointing at me?" And then they said the subject which was given was entrepreneurship, and while we were discussing, a teacher asked if there is an entrepreneur in your class, and that was me. So that is when I actually understood I was an entrepreneur. I understood I was an entrepreneur when everyone pointed at me when we were learning that you start something by your own, either for money or for some purpose, but something on your own to bring some changes, right? So there was social entrepreneurship, and then there's no normal entrepreneurship. So I was doing running a not-for-profit. So I fell under that category, and everyone were like, "We have an entrepreneur." So that is the day when I realized, and then I want to really have doctor beside my name. That is my goal even now. But after my engineering, my parents didn't allow me. I took 1 year of break to figure out what should I study, where should I apply, and the point of so many of my friends, my mentors, convincing my mom to send out, where it said it was study wherever in India. In 1 month it became study wherever in Bangalore, right? And what I wanted to study was not there. So I continued to take care of SSCID in that time, and till now I haven't got the opportunity to study. But running SSCID, and then as I said, I was not allowed to go outside Bangalore or anywhere in Bangalore also. Once I started SSCID, where we teach about space, where we talk about space for students, it has taken me to more than 8 countries to only teach about space, to only talk about space. So SSCID has taken me to different worlds. I interact with students across the country, and whoever is interested, we help them to learn more and to achieve your goals. That's it. Yes, yeah, that's another thing, a lot of things comes as a problem again, I said I come from a very middle class family, and I was one of the brightest student or the child, whatever it is. My parents had high expectation that I would get into a really good job, earn more, make my family so rich, I'll be rich and all of it. But I ended up starting an NGO where I was not making any money, right? I have to spend my money to an extent that I used to get scholarship because again I was a topper, and I used to spend that money back to the NGO, like go to different schools, put the money on that, traveling, buying some materials which would help students to learn and build and all of it. So bootstrapped again. So again, you have to have a team to do it, you need to pay them. That's again set of things that we get into, but it's a lot of things. But you should start something of your own if you really like to. Thank you.
That was really inspiring. Thank you. So now I was saving Seetha for the last, as you have probably understood by now, so what do you say?
Thank you, Nikhitha. My journey is a long one, fully in ISRO as far as my official journey is concerned. And because that takes a long time, as Nandini said, it takes over most of your life. Yeah. So I joined ISRO after my MSc in 1980. And that was very much not the exact beginning, but very much early in space arena, especially in space science. I should say this, because the remote sensing and the communication satellites were sort of getting on the rail at that, just getting on the rail. But space science had to wait for some more time. We had to wait for the Indian launch vehicles to fly the Indian satellites. So while I was doing that, I got into observing stars with optical telescopes on the ground. Yeah, my first year, by the way, was on applied physics, totally not astronomy, which I was very good at because I had studied my MSc with physics and electronics, and I loved making instruments, making measurements, analyzing that data. That was my first thing. But after that 1 year, we decided what should we fly on satellites, and that's where my connection with astronomy came. I have never, I've never seen stars per se because I have always lived in cities where my father used to get transferred, and the best thing I've seen is the sun and the moon, and that's it. But then one thing I was very clear in my MSc, if I'm going to do a PhD, I'm going to do a PhD where I'm going to work in. I don't want to do a PhD and then find the work. This was clear in my head. And so after my MSc, I said, I'm going for a job. I have to be economically independent. If, as these people said, that if you want to make some decisions of your own, you need that leverage. And those days, PhD fellowship was not that paying, okay? So, and luckily for me, even before I finished MSc, there was this advertisement from ISRO. And so straight away I applied, and within 6 months, just 6 months after I finished my MSc, I got this interview call, and I was selected. Those days things were simpler. And because I had this multidisciplinary of doing things, having electronics background, this was a plus. They thought, the interview panel thought it was a very good thing for me to join technical physics at that time. Yeah, so then after 1 year, we started working on astronomy, and that was with optical astronomy. I used to go to, the first telescope I had gone to was Cavalier telescope. Again, there were not many ladies at that time. And so they explained, so that was night work, first night shift. Night shift, we had to be on the observing floor. Nowadays you have, anybody who works on optical astronomy has these CCD cameras. They have this terminal, you can sit around and see on the terminal which field you're observing. And those days it was not like that. We would see the star atlas, take a tracing of it, go to the telescope floor and actually look through the eyepiece and see, are we seeing the right star? By seeing the field. Okay? Are we seeing the right pattern? That's the first thing of pattern recognition I learned. So, fast forwarding this, and then I went into it. So that's optical band. Then I went on to X-ray band because I went on to a rocket payload which we flew for X-rays. And after that, of course, we got opportunities with the ASLV and the experiments on Indian satellites. My first experiment was gamma ray burst experiment. Very, very topical at that time. I thought I'm going to make great things with this. But very nice experiment also. And those days, there was nobody to teach you how to build that experiment, how to cushion it, how to make it survive the launch loads and the thermovac, etc. No, not many. So we had to evolve these processes ourselves. How do we do it? And so all of us are novices. Different fields. Somebody is a mechanical engineer, somebody is an electronics engineer, and develop it. So I think I enjoyed that growth phase. And but then, unfortunately for me, the first 2 satellites didn't reach space. So my PhD got detracked from GRBs back to optical astronomy. I finished my PhD with optical astronomy data, but then it took me to the field of astroseismology, which I really enjoy because we study the interior of stars. So one thing I learned is even if you face failures, it might end up in something which you learn, and that might be even better than what you thought you could do. And of course, FOSSI and C2 worked, and we had a lot of data from gamma ray bursts, but by then CGRO had come and it overtook us. Then, of course, I worked on IRSP3 experiment, and then came AstroSat. And AstroSat is a real overall mission I worked at, where from start to continuing till now, and so I've enjoyed this journey of learning how to make things and going on to actually seeing a mission being very successful. So I have been very lucky at that, and I have gone through the same phases like Nandini has, and also the phases which Avyarthana and Shyama have. Yeah, there were fewer ladies when I joined, but there are many things have changed over the last 40 years. I'm very happy at that. Many more girls into this, and apart from the scientific achievements, I'm also very happy to state that I contributed by pushing for a crash in your satellite center, because I did it even in the early part, but nobody listened. Then towards the end, we said we need the crash, and by then we had a controller who supported it, and so we made best use of that opportunity and got the crash done. And it's functioning very well, and I'm sure my younger colleagues have benefited from it. So that's my journey. Personally, my parents said I had the same things. I was earlier than you, right? Limitations, you can do anything as a day scholar, but hostel, no, and so on. But I insisted I want to face hostel life. So MSc would be in with the hostel. BSc up to BSc, yes. So that's how I got into IIT Madras, and I did my thing in hostel. And then PhD, of course, I did after joining ISRO with the data I did for PhD, astroseismology, as I said. And here I am. So it's been a long journey, but very, very, looking back, it has been extremely good. I didn't think I would be enjoying the fruits of, for example, a successful mission like AstroSat, but I have. So, great. Thank you.
So we've heard from all our panelists. There's again some shifting at the back. We'll give them a minute to leave, and then from the people who are still in the audience, we can take a few questions. If you have a question, please raise your hand. Somebody will take a microphone to you, and please tell us who you're going to ask the question to. Which of the panelists you want to ask the question to? Questions?
Come to the center actually, there's so much space here.
There's already one person here next to you.
So good morning, ma'am. I'm Avyarthana, and I have just a small question that I'm a physics student, and I really want to go with astrophysics. I have a very deep interest on space and universe related things. And you all are in that field. So I just want to know, is physics really that hard? And since it's for women, I have some male friends who were telling me yesterday only that it's going to be hard. Just so that that it's going to be hard for a girl to pursue future dreams with maths or any science field.
Yeah, don't let anybody scare you about what you want. Yeah, don't let anybody scare you about what you want to study. If you study the subject, if you find that interesting, study. And if you think it's difficult, leave it. Both ways, take a stand. I mean, it doesn't matter. Even if you say you can't study, it doesn't matter. See, you can always do it. So either way, don't feel bad that I can't study physics or maths, or feel bad that, oh, these people are telling me that I can't study physics, so maybe I can't study. No, either way, don't do it. You do it, you study it, and if you fail, you can continue it further. And as far as astrophysics is concerned, astrophysics is a very interesting subject. Astronomy is a very interesting subject. But you should also remember that it's very fascinating as a hobby. But when you go to the core astrophysics, whether you like it or not, you will have to go through it and see. Yeah, that's something I want to tell about any subject for that matter, not just astrophysics. When you want to take it as a career, it's deeper, understanding things deeper. So find your level. It's not that what you should do is what somebody else is doing. Say, I can't do what Devleena does. He does theoretical modeling and I can't do it. And I say, I can't do this. So find what you can do and what you would like to do and match those. So that's what Avyarthana has done, right? I mean, she has done core astronomy and then joined TCS, which is a company. So you can always look for, many engineers are coming to astronomy because they like astronomy.
Thank you, ma'am. Just a last question, that is life with physics now, like you people have gone way far. So is life with physics boring? Means do you all get cut out from the luxuries and the funs?
No, it's not, right? Sorry. I was just particularly because as I said, no, I want to be a dancer, I want to write, but I'm doing physics. So,
no, when you really want to do something, I'm sure you'll find a way to do it. So that's it. So it doesn't mean if you're passionate about even other subjects, which is possible, right? If once into physics, it doesn't mean you give up everything, and isn't it? It's not an ascetic life, isn't it? So certainly, if you really want to do something, then do. I still dance. Like I had a dance program last month. That's just because I'm really crazy about it, and somehow if I get a stage, I forget I'm really tempted. I want to do this. So you can do things with life, even if you come into these fields.
Just a compliment from you all people are like very genius and intelligent. Yet you all are so cute and just like I'm really touched. I'm really happy. It's really a pleasure to meet you all. Thank you.
Hello ma'am. My question is to Nandini ma'am or Seetha ma'am. Whoever wants to answer or is interested. So ma'am, we talked about space debris. So what are we in ISRO? Are we having a set plan or solid plan in this direction? As we can see that when this is increasing at geometric and arithmetic rates, so
Do we have a set plan, solid plan on this?
Yeah. So if you have this, I was telling you this new it's a group called Netra. It's a division of ISRO where I work. So where we get information about all these debris. First of all, we're looking at the safety of our own assets, all the satellites. So we every day compute it and all the debris coming closer. And in order to avoid debris itself, what we do is when we launch the satellite, we make sure that we have enough fuel to bring it back also to make sure that it doesn't remain as debris. And of late also, in fact even this month, we have a campaign for one of our satellites. We do a Reentry campaign. So when you do a Reentry campaign, you do maneuvers to bring it back to Earth and make sure that at least we try to see that it goes to the Nemo Point.
Among the already existing debris that is there, it is also increasing. So are we thinking in this direction?
So yeah, when the satellite is live and it can take commands, you can do a reentry, but if it's defunct, it's not working, or it's a launch vehicle stage, it's a spent stage of a launch vehicle, you can't do much about it. But then that's what I said, for the future generation to come up with new techniques to clean up the debris. There are a lot of patients who are looking at very, very fancy ideas, but the technology has to come.
Thank you so much. Thank you.
Anyone else has a question?
Can we also ask questions? So I have now seen few women from ISRO, Shyama, Seetha, many more, but few of you are here on stage. And there is something that is common. You are, somebody called you cute, but I find that you're always smiling. You have this Zen attitude. Happy, you look happy. What is the secret? Because I mean, this is what we are all in search for, right? I mean, you are in this environment. I have a difficult task dealing with most people in ISRO. I didn't know that. Seetha knows this, right? What makes you? What has made you this? Have this Zen attitude, this smiling face, which is very reassuring and calming to the rest of us in a lot of ways, right? When I look at Seetha, the way she deals with people, the attitude she has, it counts me. What is the secret? What is going on?
I don't think Girish will agree with your statement, because I have had, today I'm sitting here and smiling, post-retirement and so on.
Shyama is smiling.
Yeah,
is happy there.
Yeah, she's naturally smiling. But I have had moments when I have been very, very rough. But then I realized after some time, but maybe it need not have been. I don't know the way of speaking very smoothly when I know that it's wrong. So I don't think, and I see Girish is shaking his head. I can't tell things very, very quickly. So I don't think, but then, as I said, we also have derived satisfaction from what we have done. While we are doing it, maybe we are very tough. I don't know, Nandini. I don't know how she is, but I have been tough. But after that, because for us the work is so critical, you see, you can't afford a mistake. And therefore I have been very, very critical. But once the result comes, I am very, very. I remember the first GRP we detected. I should have said. So,
Yeah. I think in ISRO, at least my team, it's more of working together as a team. You trust your people you are working with, and you can never do a satellite mission single-handedly. I mean, every person, even the canteen and the transport, everyone has to, do his job perfectly for it to be successful. So the trust we build in each other, probably that gives us, of course we've had, you might not have seen us at all times, but then another trait, especially we at mission operations, is apart from the smile, I think we've learned to be calm.
because especially when things happen, let's say something goes wrong in the satellite, you lose your cool, you lose everything. You have to have that nerve of steel to overcome that situation. That's one thing we learned with that.
Yeah, because they deal with a lot of subsystems, so lot of teams, so they learn. I learned it over, I realized I have learned certain things over astrophysics. Dealing on one hand with scientists, dealing on the other hand with ISRO engineers, I have learned a lot of things over astrophysics.
Okay, all right. Thank you.
Okay, I think we need to wrap up. Okay, last question then.
So ma'am, you said that commercialization of space is the next big thing. So what role do you think India might play in the future in that space?
So yeah, the new space reforms, right? All of you have read in the papers. It's opening up, space is opened up now to commercial startups. And there's so many people, you saw this recent launch by Bhatacharjee. They did that mission from Harinath. So ISRO is going to collaborate with a lot of private players, and there's going to be a lot of hand-holding, bringing in new people. That's what the government is saying. So it's still preliminary days.
So to answer quickly, because we are short in time, there are I think more than equal to 100 plus startups that has bloomed in the last 10 years, and when ISRO was, and please correct me if I'm wrong, when ISRO was built, the single focus goal of the country was military, was into research. But right now, in 2022, you have other application sciences opened up. Agriculture is one of the biggest, fisheries is something that we do. There is mining, there is infrastructure, there is a lot of such applications where you're seeing grassroots level or ground root or real small applications blooming. So that's the commercialization of space, and we have started coming in not only using GIS data, but also building ground stations and also launching private satellites in space. And yeah, ISRO is of course the the umbrella under which we operate, and there's the support services and the advisories come from there. So yeah.
Yeah, we know we have a lot of things on our hands, and that things which have been proven, which are in the productionization mode, can be handed over to the industry, and therefore that part can be given to the industry, and that the rest of the R&D still we need to do for the future, present and future, and that should be probably handled by ISRO. Is probably what is the thinking. I'm outside ISRO right now, so this is my personal view.
I think we'll take that as the last question and we'll wrap up. So let me first thank all the panelists for their time and very insightful speeches. And to the audience, most of them have left by now because schools have very critical timings. But anyway, let's record our appreciation for them being here. And to all of you who have been here till the end, hand over to people.
Thank you, Anita. Thank you, Anita. So I would also like to acknowledge the help we've received from the ITM, particularly Shubhata Chaudhary, Rakesh, can stand up, Mr. Rajiv here. They have coordinated with us in getting this event together, and some of my own students who have been working hard over, I don't know. I've got upset with you guys sometimes. Just call up Seetha. She'll calm you and calm me. So Yoshita, Shakshi, Chitradeep, many more are there. Many more of my students are in Science City, some are in Presidency. But yeah, thank you very much for being with us. I have some present duty now, which I will ask Seetha to do because she is the chair of the National Outreach Committee. These are gifts from us to panelists. is a mark.
Even the bag is a very useful.
Yeah, bag is also very useful. And this is a jute bag that you can even take to the market. It's not another backpack.
Where is Avyarthana's mom? Is she still around?
Yes.
I also acknowledge you for trusting your daughter with us. She's done wonderfully well, and we at SESI are very proud of what she has achieved.
Thank you.
You don't have to impose any curfew on her necessarily. Just an advice from a supervisor to a parent. I think she is just fine.
Now she knows there are many women who have gone through.
Yeah. Thank you very much for bringing us here.
Thank you.
Do you want a picture with all of them? I think, why don't you go up? When did you join? I think the students should Oh, anybody can go up. I'll take a picture. Is your camera better or my camera better?
My camera.
We're acting like men.
If any of you want to come, you just go and run.
School can go. Please don't fall out.